This is GATE 2017 set 2 electrical question number 33. A 220 volt 10 kilowatts 900 rpm separately excited DC motor has an armature resistance of 0.02 ohm. When the motor operates at rated speed with rated terminal voltage, the torque developed is 70 Newton meters. Neglecting the losses, the current drawn by the motor from the 220 volt supply is being asked. 4 options are given. For NPTEL reference, you can refer to lecture number 23 DC motors basics and speed torque relationship of the NPTEL course Electrical Machines by Professor G. Bhuvaneshwari, Department of Electrical Engineering, IIT Delhi. This is a diagram showing a separately excited motor where we have EF excitation given separately to the motor. The terminal voltage of the motor is Vt, and this is the armature current which is flowing through the motor, and Ra is the armature resistance. The Eb is the back EMF developed in the motor. So the equation can be written as, for a DC separately excited DC motor, Eb equal to Vt minus IaRa drop. And if we assume no rotational losses, then Eb into Ia is the input electric power in electrical terms to the motor, and the output mechanical power is tau into omega, which is tau into 2 pi n by 60, where n is the rotational speed in rpm and omega is in radians per second. The effective electrical input to the motor is actually Eb into Ia as seen, and tau into omega is the mechanical output. Both can be equal if there is no rotational losses, which is the ideal case assumption. Coming to the solution, the voltage is given to 20 volt, that is the terminal voltage. Torque is 70 Newton meter and speed n is 900 rpm. Ra is also given as 0.02 ohm. Hence the power P is 10 kilowatts as given in the problem. Then we can see Eb into Ia equal to 10 kilowatts, because ideal case assumption, no rotational losses, hence output mechanical power is input electrical power. Effective input electrical power is Eb into Ia, which is 10 kilowatts. So 10 kilowatts means 10 into 10 to the power 3 watts. Now Eb can be written as Vt minus IaRa, this into Ia, equal to 10 into 10 to the power 3. 220 minus Ia is not known, into 0.02 ohm into Ia equal to 10 into 10 to the power 3. From this, Ia is coming out 45.75 amperes, taking the positive value, as Ia must be greater than 0 for electrical motors as per the assumed direction of Ia. Now power is also tau into omega. Here mechanical output equal to effective electrical input after armature drop, that is IaRa drop. After that, the remaining electrical power goes into producing the rotational energy. So we have not assumed any rotational loss. So the torque is coming out to be 10 into 10 to the power 3 divided by 2 pi into 900 rpm into 60, because omega is 2 pi into n by 60. So we are getting the torque to be 106.15 Newton meter. For 70 Newton meter torque, Ia is being asked. Now this torque is proportional to Ia into phi, but phi is fixed. T1 by T2 equal to Ia1 by Ia2. Now tau 1 is 106.15, tau 2 is 70 as given, Ia1 is known, which is 45.75, Ia2 is being asked. The current drawn in this condition when 70 Newton meter is the torque produced is found out to be 30.16 amperes. So the answer is 30.16. So 30 amperes. Option B is the correct option. Thank you.